Okay, today we're going to do sequences. Next time we'll do series, and I think I'm going to have us do polar graphs just because they're fun to do. There's not a whole lot of computation involved in that. So we'll do sequences today, next time series, and then polar graphing. So we'll start sequences. And you did all of the sequence stuff last year, or you should have. So this section should be a review. I'm not going to explain everything in great detail. I'm just going to kind of overview sequences today. So a sequence, that's just a list of numbers that have a specific pattern to get from one number to the next. So if I had, actually I don't need to show you one of those. I guess I can. So let's say a 1, 3, 5, 7. You recognize this. This is a sequence of odd numbers. And you know to get from 1 to 3, you add 2, 3 to 5, you add 2, 5 to 7, you add 2 as well. All right. So just a few things for notation for sequences. We always use these little A's to describe the terms or the elements in our sequence. So A sub 1, the number of the subscript is the term number that you're on. That means first term. So that's the first term. A sub 2, that is our second term, and so on. But what we also use is if we don't know what term that we're looking for, or if we want to make a general equation that would work for any term, this is going to be A sub n, and whatever term you want to find, if it's the fifth term, you would use 5 for n. If it was the seventh term, you would use 7 for n. Okay. So that's your nth term, where n stands for whatever term you're looking for. We just use that kind of like a variable. And then we also see this a whole bunch. We see A sub n minus 1. So the n minus 1 is in the subscript. And this one just means that the term that came right before. Before n, whatever n is. So if I wanted to say like 7 is the fourth term, so that would be A sub 4. And 5 is the term that came before that, so I could say A sub 4 minus 1, because that's one term before it, which we know 4 minus 1 is 3. That's just another way for us to put in an equation that this is the one that came right before, so that's going to come up a couple times. If you had n minus 2, it would be 2 terms before. N minus 3, 3 terms before. So the term that came before n, whatever n is that we're talking about. So that's all of our notation for our sequences. We have 2 types of equations that we're going to use, or formulas for sequences. The first one is explicit. And an explicit formula just tells you exactly what the numbers are in the sequence. You can plug a number in and figure out what it would be. So the one you might be, well, we'll just do one. I'll make this one up for this to work out. So if I said A sub n is equal to, sorry, 2n minus 1, this is going to be your formula for all of the numbers in your sequence. If I wanted to find a specific term, like the fourth term, I just plug in 4 for n. If I want the fifth term, I plug in 5 for n. This is actually this equation for this sequence. So if I did plug 4 in, 2 times 4 is 8. 8 minus 1 is 7. That gets you the numbers. So if I wanted to use this formula to find like the 10th term, A sub 10, I'd just say 2 times 10 minus 1, and that is 19. Okay? We're going to go through in a minute how to come up with these equations. I just wanted you to know that that's what an explicit formula is. So an explicit formula tells you specifically what every single term is. You can get it just by plugging the number in. So that is an example of an explicit formula. All right, recursive is the second type. A recursive formula, means you're going to do something again or over, and that's what we're going to explain in the recursive formulas. They have 2 parts. You're going to first tell whoever is trying to write this sequence out the first term. So my first term, if I'm going to do this one, is 1. And then you're going to tell the person how to get to the next number and the next number and then the next number. This is kind of what we were doing at the very beginning. So how would you go from 1 to 3? Well, we had to add 2. So when we write that out, so to get to the next term, or whatever term that we're looking for, we go to the one that came right before it. So if I wanted to figure out the second term, I go to the term that came before it, and we write that as a sub n minus 1, because that's how we represent the term that came before. And then what did we do to get from there to there? Well, we added 2. So if you wanted to find the fourth term, you go to the term that came before, which was the third term, and then you add 2. Okay, recursive formulas are good to get a sequence started, but they're not good to find like the 100th term. Because if you wanted to find the 100th term, you'd have to have the 99th term, and then to find the 99th term, you need the 98th term, and so on and so forth. So if you're trying to figure out a long way down the line, you'll use explicit. If you just want to describe a formula, or if you just want to find the first couple terms, recursive formulas are the way to go. And they're really, I think they're easier to write and come up with than the explicit formula. All right, so those are our 2 types of formulas that we're going to use, all of our notation, and then we'll talk about 2 specific types of sequences and what their formulas are for their explicit. And we'll do recursive as well. So I'm just going to make a chart for these 2 types, and we'll kind of compare them as we go along. And you've heard these words before. There's arithmetic sequences and geometric sequences. Arithmetic, you are going to add or subtract the same number in between all of your terms. Okay, and that number is called the common difference. We use a D for that. For geometric, you're going to multiply by the same number each time. It can be a fraction, so that's why we think maybe you're dividing each time. That works as well. So you're going to multiply by the same number. And that is called the common ratio. All right. So if we think about the explicit formula that we need for an arithmetic sequence, if we just have the one that we just had at the very beginning, we've got 1, 3, 5, 7. Let's say that we want to do a couple more, 9, 11. So say we wanted to we started at 1, we're going by 2s each time, and we want to know what the 6th term is. So for us, it's pretty easy just to write that out, but we can figure out how we could use a formula to figure out what our 6th term was. So we started with 1, and then how many times did we have to add 2? We added 2, 1, 2, 3, 4, 5 times. So to find the 6th term, you had to add 2, 1, 2, 3, 4, 5 times. Okay, that's because you already knew what your first term was, and you had to just increase it 1 fewer than the number of terms that you're trying to look for. So if we wanted to write this out in this equation, we added our common difference, 1 less than the number of terms we're looking for, right? And we added that to our original number. So our explicit formula for an arithmetic sequence is whatever term number we're looking for. You start with the first term, and then you are going to add your common difference. So we did this one 5 times, but we were looking for the 6th term. So we're going to say n minus 1, because that would be 6 minus 1. That's going to give us the 5 times the common difference. Some people like to put the common difference, the d in the front. That's fine too. So you could write it that way. A sub n is the first term plus the common difference times n minus 1, where n stands for what term you're looking for. So we could just plug this in. If I'm going to do this one, this would be the 6th term. So a sub 6. What is the first term? That's our 1. Our common difference is 2. We're looking for the 6th term, so I'm going to say 6 minus 1. That means I added it to 5 times. And this is just 1 plus 2 times 5, and that's going to give me 11. So I can find the 6th term doing that. If you're just asked to just write the equation out, you're obviously not going to plug in anything for the n here and here. You just plug in the first term and the common difference. So the general explicit formula is just a sub n for this particular problem is 1 plus 2 times n minus 1. Okay. We can also do recursive with this. So this one was explicit. Recursive, oh, we already did recursive for this equation, so we don't really have to do it again. But just so if you wanted to have it down here, for recursive, your first term is 1. To get to the other terms, you do the 1 before plus 2. All right, so that's recursive for arithmetic. That's our explicit for this particular arithmetic. This is if you want to actually plug a number into the explicit formula. If you're looking for a specific term, you put it in for the n. That's the term number that you were looking for. Okay, so those are arithmetic sequences. Now we'll go to geometric, where we multiply each time for our common ratio. We can do a pretty basic one. Let's just say I have 4 and then 8 and then 16, 32, ... So for this problem, it looks like we are multiplying by 2 each time. So times 2, times 2, times 2. So our common ratio is 2. Okay. If we want to figure out how to make an explicit formula, we start with our first term. And then we had to multiply by 2 3 times. Like if I'm trying to find the 4th term, let's say I just wanted to find 32. If I start with 4, I'm going to multiply by 2 1, 2, 3 times. So to write that out in a formula sense, any given term is the first term times the common ratio. And instead of doing, since we're doing multiplying it by a certain number of times, we're going to use an exponent. So we'll multiply it in minus 1 times. So that is our formula for geometric. This is the explicit formula that you're going to use if you're going to plug things in. First term, common ratio, raised to the n minus 1. So if I wanted to do this one, the first term is 4, common ratio is 2, and raised to the n minus 1. To find a specific term, say I wanted to find the 6th term for this problem, a sub 6 is 4 times 2 raised to the 6 minus 1. And I think that would be 128. You just type that in the calculator. That's fine. Okay. So that's the general explicit formula for geometric sequences. This is the one for this particular problem. And then if you wanted for a particular number, you just plug the number into the equation. And then the last thing, recursive. For this one, the first term that we see is 4. We always have to say the first term. And then any term that comes after that is the term that came before it times 2. All right. Okay, and I think that's all for sequences today. Remember, we'll do series next time and then polar coordinates. Thank you very much.